Okay, in this video, we're going to learn how to solve right triangles when we don't have two side lengths, so only one side length, and it's not a special right triangle. And the process is very similar to special right triangles. The idea is very similar to special right triangles, as we'll see, but the difference is you need a calculator to do these. You don't need to have the ratios between the sides memorized. So sine, cosine, and tangent are three trig functions. So trigonometry refers to the study of triangles and their angles and their side lengths. And we'll learn about what sine, cosine, and tangent do. But first we're going to focus on tangent. And before we even get there, I just want to go over a couple basics. So when we have a right triangle, as we do right here, you have a right angle and you have an acute angle. So the acute angle is represented by this symbol right there, and it's called theta. Now, the opposite leg and the adjacent leg are legs, so they have to form the right angle. So the opposite leg is the side across from theta. Now, theta could be an angle that you're given or an angle that you're looking for, and it has to be an acute angle. So theta could be this angle, or it could be the other acute angle. It doesn't matter. Just establish at the beginning of the problem which angle you're going to use. All right, so we're going to use this lower left angle. All right, so the opposite leg is directly across from theta, and the adjacent leg is next to theta. Oops. And then the hypotenuse is always the biggest side, and it's always across from 90 degrees. So you can think of hypotenuse, hippopotamus, they're both big, they're both the biggest sides. All right, we need to know which side is the hypotenuse. It's always across from 90, and then opposite and adjacent are always the legs. Now, if you drew the triangle like this, where theta was now up there, all right, this would still be the hypotenuse. That doesn't change, but the opposite leg now would now be this one on the bottom, the one across from theta. Whoops, sorry, I'm having some difficulties here. All right, that's the opposite leg, across from theta. And then the adjacent leg is right next to it. All right, so that's an important concept that we need to start using trig.